This is section 11.1, goal 3, finding limits using the tabular method or numerically or using a table. And we're looking at example number 2. Ask us to evaluate the limit as x approaches 2 of x squared minus 4 divided by x minus 2. Okay, so we will type this in our calculator in a moment. But let's go ahead and factor the numerator, and when we factor the numerator, that's x plus 2 times x minus 2, and that is divided by x minus 2. Now, the first thing I notice about the numerator and the denominator after I factor is that the x minus 2's will cancel. So that tells me that there is a hole where x minus 2 equals 0. So we know that there is a hole at x equals positive 2. Now remember, a hole is nothing more than an ordered pair that is open. So an ordered pair has an x-coordinate and a y-coordinate. So to calculate the y-coordinate of our ordered pair, we'll look at the remaining function. The remaining function is x plus 2. So if we plug in positive 2, 2 plus 2 gives us a y-coordinate of 4. So that tells me when we graph the function, we have a hole at 2, 4. Now that we have reduced the function or factored and canceled, it's gone from a rational function to a linear function. And our linear function is x plus 2. So we have a y-intercept of 2 and a slope of 1. So up 1, right 1. Up 1, right 1 gets us to our hole. Or we could go down 1, left 1, down 1, left 1, and so on. So take a moment and sketch x plus 2 with a hole at 2, 4. Okay, so here is our graph. Let's go ahead and find the limit. As x approaches 2, there's no plus, there's no negative following the 2, so that means we are approaching 2 from both sides. So as x approaches 2 from the left, y approaches 4, and as x approaches 2 from the right, y approaches 4. So it appears that our limit is x equals 4. Now, I know that our goal is not to find the limit graphically, but to find it tabularly or algebraically. So let's use our table and see if we come up with the same limit. So come down to our table, and I'm going to go over to the middle and put positive 2. That's the value that we're finding the limit as x approaches positive 2. Remember, we're looking for where we are very close to x. So we want 2.00 to the right, 2.001, 2.01, and 2.1. So to the right side of our value, we've added 1,000th, 100th, a 10th, and we'll subtract that from the left-hand side. So when we subtract 1,000th, we have 0.999, 1.999. When we subtract 100th, 1.99, and when we subtract a 10th, 1.9. And these are the values that we're going to use in our calculator. So at this time, let's use our calculator to calculate the table. Now, it's important that when you type the function into your table, you type the original function, not the simplified version. So add a graph, type in x squared minus 4 divided by x minus 2. If I'm ahead of you and you need to pause the screencast, go right ahead. And here's our equation. Now be aware that your calculator does not plot the circle that should be right here, that open circle or the hole. Your calculator does not plot that. However, it will show up in your table. Remember to turn on your table. You may press Control T or Menu, number 7 for table, split screen table. Notice that our X values are not what we want. So let's immediately go to change our X value or change our table settings. Menu, Table, Edit Table Settings. Remember to change the independent to ask. It does not matter. You definitely want the independent to say ask. That represents your X coordinate, and the dependent to remain auto. That is your Y coordinate. It does not matter what the start and step are. Now we have the opportunity to enter our values. I always want to enter my values on my table and my calculator from greatest to least or least to greatest. It's important that you do one of those two things, not out of order. So greatest to least or least to greatest. So I'll go ahead and do 2.1, 2.01, 2.001, and 2. 1.999, 1.99, and 1.9. Okay, now we look at, Mommy is, so let's look at our values. I see that as my X coordinates get closer to 2 from the right, my Y value is getting closer and closer to 4. As my X values get closer to 2 from the left, my Y values are also getting closer and closer to 4. So pause the screencast and transfer these values to your table. So checking again from the left, as X gets closer to 2, it appears that Y is getting closer and closer to 4. 3.9, 3.99, 3.999. It looks like we're getting really close to 4. From the right, 4.1, 4.01, 4.001. We are getting really close to 4. So from the left and from the right, the limit is approaching both values. Those two Y values are equivalent. We're able to pinpoint one Y value. Here's X is 2, Y is approaching 4. So our limit is 4. Now I want to point out, and I know we discussed this in class today, but I want to say it one more time. A limit can still exist even if the function is undefined where X equals C. And the function is clearly undefined at X equals 2. If we plug 2 back into our function, we would be dividing by 0. That's why we have a hole there. So the hole does not affect whether or not the limit exists. Let's look. I'm going to stop the screencast and make a separate screencast for the following example.